All right, we're on to the practice stuff. You should have got a lot of practice in class, and you should have got some practice looking at the videos, either way. So we're going to go to the practice answers, explain them. Hopefully it makes a little bit more sense. If it doesn't, make sure you ask questions. So when two atoms of carbon form a double bond, keyword double bond, how many pairs of electrons? So you got to think, each bond contains 2 electrons. So if you have 2 bonds, which is a double bond, you have 4 electrons being shared, because each bond counts as 2. If you have a double bond, it's going to be 4. Which of the following compounds is formed by a covalent bonding? When you have covalent bonding, think non-metals. Okay, these are the type of elements you should look for. So on your periodic table, there should be a little line or a stair step that divides the metals from the non-metals. Covalent bonds generally happen between just non-metals. So over here, sodium, that's a metal. Aluminum, that's a metal. Lithium, that's a metal because it's on the left side of the stair step. These molecules are all non-metals, okay, except for hydrogen, but that doesn't really count, kind of a certain exception. All right, so this is going to be a covalent bonding because it only has non-metals in it. Which of the following molecules contains a non-polar bond? So you got to think, non-polar stuff is between non-metals or organic compounds. All right, so here we go. Non-polar bond. Geez, it could be this one, could be this one, could be this one, could be this one. Oh, they're all non-metals. All right, so a non-polar bond means there's no charge. In other words, there's no electronegativity differences between them. So the only way there's going to be a difference between them is if they're the same element, because they're going to be equal. So F2 would be the best answer, even though all these would be kind of fall in the realm of non-polar maybe. Which of the following molecules is polar? So polar, you got to think, which one has the greatest distance between it on the periodic table? Well, these are all the same molecules here. This is the one that has different atoms. It's got to be that one because they're the furthest apart. That's your general rule. So polar, usually the furthest apart on the periodic table. Non-polar, closest together. Which of the following non-polar molecules has the lowest boiling point? So you got to think, lowest boiling point means they have the least amount of carbons. So we're looking for the least number of carbons. 1, 2, 3, 4. We're going to go with 1. The least amount of carbons there. Number 8. Which of the following molecules is tetrahedral? In other words, it has 4 things bonded to it. Well, this one only has 2. This one has 4. 1 and 1. Oh, it's got to be this one. 4 things bonded to it. Because remember, carbon forms tetrahedral. Whoops. What am I doing? Wrong answer. I wasn't even looking at the right one. Either way, it's still this one. 4 things bonded to the carbon. All right. Which of the following substances is a poor conductor that melts relatively low temperature? Well, it's going to be an organic compound, which is that one. So either way, I was right on both sides. Nice job. All right. So tetrahedral, 4 things bonded to it. Poor conductor, melts at low temperature. It's going to be an organic molecule. This is the only one that's organic because it contains a carbon. Which of the following substances is organic? Well, look for a carbon. No. That, by the way, that's a lowercase l, not an I. No. Yep. There it is. So organic means carbon. Which of the following substances is insoluble in water? Well, it's going to be most of your organic substances are going to be insoluble. Oh, that's not organic. That's non-polar. That's organic, but this is not organic. Not organic, not organic. So insoluble is going to be your organic compound. All right? Now, here's a quick question. This is from your notes on the very beginning. An organic compound is heated in the presence of oxygen. Ooh, that sounds familiar. Check a look at the reaction. High enough temperature. What chemical reaction will take place? A combustion. Remember, in a combustion reaction, reacts with oxygen in the presence of oxygen, and it's going to make CO2 and H2O in any number. All right, a couple other practice ones. Name the following compounds. C2H6. Ooh, if I drew this, so if I name that, there's 2 carbons. F. Now I got to think, is there single, double, triple bonds in this molecule? And if you drew it, you would find out there's only single bonds, so therefore it's ethane. Okay, so ethane. 3 carbon molecule, 1, 2, 3, 4 hydrogens. Remember, each carbon wants to bond 4 times. So let's say I have 1, 2, 3, 4. Okay, so I only have 4 hydrogens. I can't add them. So this carbon right here is bonded 4 times. This one's good. This carbon here is only bonded 3 times. This carbon here is only bonded once. How are we going to make this work? All right? So the best way of doing this, let's say we add a double bond. Could work. All right? Could work. So we look at this and say, yep, we had a double bond. Now this one's good. This one's good. This one still only has 2. It needs 4. So now I got to start moving some hydrogens around. So I got to say, well, maybe if I take this one off and move it over here, now how does that look? Well, now this one doesn't have 4 bonds. This one still has 4 bonds. This one only has 3. How am I going to do that? Now, maybe, what if I took that off, made a double bond here, took this off, so now I have a hydrogen here, a hydrogen here, and a hydrogen here. Okay, let's check this out. Middle carbon has 1, 2, 3, 4. Yep. Outside carbon, 4 bonds. Outside carbon, 4 bonds. Ooh, I did it. Took a little plug-in chugging, but you had to do it. 3 of them, so it's a prop. 2 double bonds, so it's a propene. Okay, and if you want to get real technical, because there's 2 double bonds, it's a diene. So propene would work. If you said 1, 2 propene, that would work. But actually, it's propadiene, which, tough one. But I would take either of those answers, so just make it sure it makes sense. C4H8. 1, 2, 3, 4. I only have 8 carbons. Well, if you look at the general formulas from the very, very beginning, which one has the same number, has double amounts of your compounds? And those ones would be your alkenes. So if I go 1, 2, 3, 4, 5, 6, 7, 8, something like that, then these guys both need a double bond. There we go. Here's my butene, because there's a double bond, and it's going to be off the second one, 2-butene. Second one, double bond. Draw the following molecules. You gotta think single, double, triples. So here we go. S means 2 carbons, single bonds, and then the hydrogens just fill in the extra blanks. All right. Propene means 3 carbons, 1, 2, 3, and that means there's a triple bond. So 1 we go here like that, and then we just fill in our hydrogens where we need them. There's propene. It could be that way too, or you could draw it like this. That would work too. 2-hexene tells you that I have 6. 1, 2, 3, 4, 5, 6. And off the second one in, I have a double bond. I could count from left to right or right to left. So I'm going to go this way. There's my 2-hexene. Double bond there. 1-butene. 1, 2, 3, 4. It's 4 off the first one. Like that. And don't forget your hydrogens. Pentane means 5. Ane means single bonds. Don't forget your hydrogens. I'm not going to draw them all in. You guys should be getting used to that now. 2-pentyne. Tyne means there's triple bond. Pent means there's 5. So off the second one, triple. And we go 1, 2, 3, 1, 2, 3, 1, 2. There it is. All right, so there's some basic drawings. Hopefully they help you out a little bit. Next one would be explain in detail what the name means. The 3 tells you location of the double bond. The hept tells you longest chain of carbons, which in this case is 7. And the ene tells you you have a double bond. There you go. So every part of this word means something. You just have to make sure you understand what it means. Let's keep going, see if we can knock some of these out. Name the following. 3, so this is going to be prop, single bonds, ane, and it's going to be a 1-chloropropane. 4, this is a but, and there's single bonds, so it's a butane. Off the second one, so I have, all right, tell me where every carbon is located, every chlorine is located, so it's a 2,2-dichloro, okay? 2 and 2, that tells you the location of each one. Di means there's 2 chlorines in each one. 1, 2, 3, 4, 5, so I got a chain of 5. Pentane, so let's say I stuck with this might be in my longest chain. Off the second one in, I have a methyl group, a 1 carbon hanging off the main chain. This one would be a 1, 2, 2 fluorines, difluoroethane, 2 carbons. This one here would be a 1, 1 difluoroethane. This is a tough one. We got 1, 2, 3, 4, 5, 6, 7 is my longest chain. So here's my longest chain right here. So 7 means I have a hept, all single bonds, heptane. Then off the second one in, right here, second N, 1, 2, 3. So we go 3, 4, 5, 2, 5. Dimethylheptane. Dimethylheptane. All right, so hopefully you made it this far. I'm going to continue with the other ones in the next video to make the video a little bit shorter. Make sure you try the other ones before you try to get the answers.